Hello, my name is Vlad and I am one of the Lynxdash founders. Lynxdash is a platform for developers that allow them to create cloud infrastructure in minutes. With Lynxdash, you can create databases, API, cloud storages, as well as execute serverless functions. But that's not the full list of available services. There are many additional services available to users, from cloud registry to user authentication and analytics. In this video, I'll show you how to start your first project, how to create tables in databases, and how to establish an API. To start your project, you need to open the project's console. Let's create an account using the registration form. After the registration, we will go to the project panel and create a new project. In this example, we will make an online store. On the main page of console, you can see available quotas for your project, project performance, and publishment status of project's components. First of all, let's create some tables in database. We will go to Schema Editor and create our first table. I need some users in my store, so I'll name my table user and will make this table public. Checkbox public means that a public API will be created for this table. Now, let's create a new table with name product and write a description for it. If you didn't make it public while creating it, you can do it later in the Edit panel. I will create a new table named Orders and make it public too. Let's start with editing the user table. In my store, I want users to have several fields. Field name. This field must be required. Field email. This field must be optional. Field phone. This field must be required, and since I plan to make queries by this field, I'll add an index to it. Checkbox index means that the new index in the database will be created and requests will be processed faster. The next field is bio. It will be optional. And also status. This field will be required and will take Boolean values. So, to create user account, I will need to fill out name, phone number, and status. The rest of the fields are optional. We will save our changes and proceed to the next table, product. I will make it public, so there will be a public API created. All products must have names, so I'll add name field. It will be required and I'll add index to it. The product will have a price, the field's type will be set to float, and I'll make it required too. I'll also add stock field for storing information about product stock. Field type must be integer. I'll add two optional fields now, description and image. Let's save our changes and proceed to the order table. In the order table, I want to store my orders hash. It will be required and have an index. I'll also store the price of my order in a float type field, which will be required to fill. My order must be linked with some user, so I'll add user field with related field type and link it with the user table. It will be required to fill as well. Every order must have a list of linked products. That's why I'll do the same operation here as I did with the user table. And we'll make field multiple. Multiple checkbox means that this field will be cast as an array of values. Also, I'll add an optional comment field and required status field. Saving our changes, and that's it. The database schema is ready for publishing and the public API can be created. My database has user, product, and orders table. To make an order, I will need values from user and product tables. To publish my changes, I'll need to press the publish button. After pressing the publish button, there will be an alert that changes were made in the database and that they need to be confirmed. After the confirmation, we can return to the main page of console and monitor publishing status. At this moment, its status is in progress and it will be changed to done in some minutes. After that, our component will be ready to work. While database is setting up, let's check our API Explorer. This section contains examples of requests to our public GraphQL API for each public table. For example, to create a user, I need to mutate the user function with selected values, but I need to change the values to the data I need. Response from the API example can be seen in this column. There are 4 CRUD operations available for each model: creating, reading, updating, and removing. After choosing a table from the list, you can see all available operations that you can make with this table. Requests to those tables that contains fields with related data type will contain fields of the linked tables. When executing such a request, you can expect a specified response from your API. When executing create mutations, you will need to specify an ID of the entries that you want to link with this entity. You will need to do this in related field types option screen. Let's return to our component. As we can see, our component is ready to work. To execute a request to our API, we will need this endpoint. To make sure that the component was set up correctly, we will go to this endpoint in the browser. As we can see, our API says that our request isn't authorized. To authorize our requests, we will need an API key, which we can find in the project settings panel. Using this key will allow us to execute authorized requests to our API. Let's use Postman to make some tests. Our API receives POST requests at our endpoint. We will also need an API key from the project settings panel. We will insert it in the header authorization. Let's proceed to the body panel and select the GraphQL type. Let's try to execute a request to read the user. We will go to the API Explorer section, select the user table, and copy the code from the read section. As we can see from the response, our table spits out an error. This is due to the fact that there is no data in the table yet. Let's return to the API Explorer and copy the code from the create section. We will also need values from the variable field. Let's fill them with some data. After executing this code, there will be an entry with specified fields added in our database, and we will get the response from the user model and its ID. Let's retry our request for reading and see the results. As we can see, we got a response with our user and his ID, which is 1. We can also execute a request to get the user list. Let's create some products now. We will copy the mutation for creating the product and the variables that we need. We will fill it out with some data. Now pay attention. Because the image field is optional on our table structure, we can leave it unfilled. As you can see, after executing this code, the optional fields contain the value of null, since we didn't fill it out. Other fields contain those values that we've sent them. But if we remove the required field, we will receive an error that the requests lack the required fields. Let's create another product with new name. This new product will have ID 2, but I want to update its description and image. We will use an update mutation for this. We can use the same variable, but we need to write an ID of the product that we need to update. In our case, the ID will be 2. As we can see, this product has an image now. We can check it by making a request for it. Let's now create our order. We will use create mutation for this. This mutation differs from the others. It contains fields of linked tables, user and product. Let's edit this list. We can just return user ID and names here. For products, we will leave image, price, name and ID field. Let's copy variables and fill out these fields. Keep in mind that for linked tables we specify the ID of the entries from these tables. We will send a request to our order and it will be created successfully. Our order will be linked with user with ID 1 and products with ID 1 and 2. Let's take a look to the data that we wrote in the table. By using Lynxdash direct connection service, we will connect to our database and see order, user and product tables. Order product table contains links between products and orders, because an order can be linked with lots of products. We can see the table schema, where we will see required and optional fields, as well as the fields with indexes. All optional fields are filled with null by default. Thanks for watching.